things that we'd already seen before. So we looked at equivalent fractions. So fractions, although they are different fractions, they are the same, similar as like 1/2 was 2/4, and 1/2 can also be 4/8. And so today we're looking at fractions that are greater than 1. So first of all, we're going to warm up. We've got 4 questions for you here. 24 divided by 4. How many tenths is in 1 whole? How many tenths are in 2 wholes? And 4, how many hundredths are in 5 wholes? If you want to pause and give that a go, please do. Okay, actually what I'm going to do is I'm going to see if we can get the whole slide and get it properly. There we go. And so, if you have paused and you've had a go, 24 divided by 4 is, of course, the answer is 6. So 6 fours is 24. How many tenths in 1 whole? We know there are 10 tenths in 1 whole. So that will help us with this next question, number 3. How many tenths are in 2 wholes? We just double that. 2 times 10 is 20. And then how many hundredths are in 5 wholes? And we know there are 100 hundredths in a whole. So in 5 wholes there will be 500 holes. 500 hundredths, sorry, not 500 holes. Oh, that'd be some working out, wouldn't it? Okay, let's learn. Let's get on with what we're doing. Okay, so as you can see, it was a fraction, and that is showing 7/7 on the bar model, which we more often than not, instead of saying 7/7, we say 1 whole, because it's 7 parts of 7 that are being highlighted. Then underneath we can see another bar model, but this time how many pieces are being shown? How many pieces are highlighted? Again, it's sevenths. Yes, 2/7. So we've got 7/7 and we've got 2/7. And if we take them as a whole, what we can say is we say, right, there are 9/7 altogether. And that is a number bigger than 1. Another way of looking at it, again, so we can take our 7/7 as 1 whole, and then we can take our 2/7. And going back to when we did our division problems, we can say there are 9/7 altogether. We can say, right, how many 7s in 9? We know there are 1. There's 1 7 in 9, but then there are 2 left over, 2 remainders. So there's 1 whole here and 2 7s. So 9/7, instead of saying 9/7, we then say, because it's an improper fraction, we say, right, we've got 1 whole, which is a 7/7, and we've got 2 7s. 1 whole and 2 7s. Having a look at this fraction here, you could tell me what this one is. Having a little look. So we count the whole, we count all the spaces first of all. So it's 1, 2, 3, 4, 5, 6. And then we count how many are highlighted. And there are 2. So we know that's 2/6. Down the bottom, we can now see there are 1, 2, 3, 4, 5, 5/6. So if we add the 2 together, 2/6 add 5/6. Remember, when we add fractions, we only add the top number. We only add the numerator, which is the top number. We don't add the denominator. That stays the same. So if we have 5 and 2, it makes 7. So we've got 7/6 altogether there. Now thinking back to what we've just looked at, instead of saying 7/6, what can we do? There are 7/6 altogether, but what we can do is we can say, okay, how many 6s go into 7? We know that's 1. So we're using our division skills again. We know that's 1. And how many are left over? It's 1. So we could say it's 1, and it's showing it really nicely there, 1 whole and 1/6. So 7/6 equals 1 whole and 1/6. I'm going to show that again because I like the way it moved up there. So what they've done is they've taken those to make 1 whole. See that really clearly with this bar model. 1 whole and 1/6. So there are 7/6 altogether. 1 whole, 1/6. Okay, so now having a look at this one here. We've got number 1. Have a think. So it shows these are fifths, because we know that the whole bar shows 5 sections or fifths. And now we need to try and work out how many altogether have been highlighted. So on the top one we've got 3, on the second one we've got 3, and on the bottom we've got 5. So we've got 3/5 and 3/5 and 5/5. Okay, so that altogether and we can add those together. So 5 and 3 and 3 is 11. So that 11 fifths altogether. So again, we can think, right, okay, using our division skills, how many fifths or how many fives are in 11? And we know there are 2 because 2 fives make 10. So that means there are 2 and there will be 1 left over. Okay, so we're thinking about that as our answer. 11 fifths altogether, so 11 fifths equals 2 wholes and 1 fifth. 2 wholes and 1 fifth. And now we've got this one at the bottom, which is unusual because there's halves. Okay, and we can see there are 3 halves altogether. So 3 halves, and this is quite nice and visual, this one. It's quite simple. I think it's easier than the one above. It says there are 3 halves altogether. 3 halves equals how many wholes and how many halves? Have a little think. I'm hoping at home that you said, yeah, 1 whole and 1 half. Totally right. Yeah, we can see that there, and it's nice and clear on our bar line of 1 whole and 1 half. So 3 halves is 1 whole and 1 half. There we go. There's our 11 fifths, 2 wholes and 1 fifth, and at the bottom, 3 halves equals 1 whole and 1 half, which is what we said. Okay. It's time for you to have a turn, and there'll be some questions on your worksheet. Just go to one from questions 1 and 2 to start with, and then once you've done question 1 and 2, come back and we will carry on with the rest. So you might want to pause this, do questions 1 and 2, and then come back. See you in a while. Good luck with those. If you're having any problem, you're a little bit unsure, you can always log on to our live stream, which is on the link that we normally use. Go to meeting and you can get some extra help there. Okay, see you soon. Thank you. Right, moving on to our next one. So we've got 12/6, and I mentioned this before. 12/6 is an improper fraction because the number above the numerator is bigger than the denominator. Okay, so we've got 6/6 equals 12/6. Well, we could say it another way. How else do you think we could say it? It's 2 wholes, yeah? How many 6s go into 12? 2. 6s into 12, 2. And it doesn't leave any over. There's no remainders, or there aren't any 6 left over. That goes in, like that divides in just right. Then we've got 6/18. Have a little think about this one. How many 6s are there in 18? And again, if you wanted to, you could draw this out. Okay, you could draw 6 just like this to help you out. And of course, you know there were 3 6s in 18, so that's 3 wholes. Okay, 3 wholes. How about if we had 24/6? And this isn't on the slide. This is an extra challenge for you. If we have 24/6, what would that be? Have a little think. Draw it out. How many 6s in 24? Pause if you want to and have a go. If you've unpaused me, I'll give you the answer. It's 24/6 is, of course, 4 wholes, because 6 into 24 goes 4. So 6 fours, 24. And that's it, 4 wholes. So 6 times 3 is 18. 18 divided by 6 is 3. So again, it's a little bit, all those skills that we've used in the previous weeks, the multiplication skills, the division skills, they're all being used for our fractions this week and for today. 18 is 3 times greater than 6. 6 divides into 18 3 times. So we've got 5, we've got 20 fifths. Can you work out that one? 20 fifths. How many times do we times 5 to get 20? Or how many 5s are in 20? So multiply 5 to get 20. How many? And how many 5s are in 20? Of course, we can then have a little look. And the answer is 4. 4 wholes. 5 times 4 is 20. 20 divided by 4 is 5, and that gives, there we go, look, just what I'm saying. 5 times 4 is 20. 20 divided by 5 is 4, so it's 4 holes. 20 is 4 times greater than 5. Now this one's a little bit harder, because this one doesn't divide quite the way that the others did. So we've got 10 sixths. Okay, can we work this one? How many sixes are there in 10? Now I know there are 1. We can only go 1. Okay, if we have 2 sixes, it would be 12, and that's too big. Okay, so there's 1 6 in 10. So we've got 1 6 in 10. How many sixths are left over? So we can count on, we can use our fingers, we could draw this out. 7, 8, 9, 10, 4. So 1 whole and 4 sixths is what I'm going for. So there we go, there's our 6, there's our 6 sixths, and just below there's 4 sixths to make 10 sixths, because 6 add 4 is 10. Okay, it makes 1 whole and 4 sixths. Spot on. Let's have a little go with these. Let's have a think. So we've got the top one, number 1. We've got 11 thirds. We've got 11 thirds. So, how do we do it again? We have a think. How many 3s are in 11? And again, we can count in our 3s. So we go 3, 6, 9. That's 3. I can't go anymore, because if I go one more, it's 12, and that's too many. So 3, 6, 9. Okay, so that's 3 holes. So I know that's 3 holes. How many are left over? 9, 10, 11. We count on. It's 2 more. So it's 3 holes and 2 thirds. Right, so I go this one at number 2. We've got 9 halves. We could say 9 tooths, but it doesn't sound quite right, does it? So 9 halves. So how many 2s are in 9? And again, we count 2, 4, 6, 8. I can't go any more. If I go more, I'll go to 10. So it has to be 8. So there are 8. So there are 4. Sorry. 4 times 2 is 8. So there are 4 holes. But how many halves does that lead us? So 8 to 9. 1 more is half. So 4 holes and 1 half. 4 and a half. 4 and a half is 9 halves. And at the very bottom there, quite a tricky one, because we've got 20 sevenths. And we look at that and we say, right, okay, how many 7s are in 20? And we go 7, 14. We can't go another one, because of course that would be 21. So there are 2. So we know there are 2. 2 holes, because it takes us to 14. So now we need to go from 14 to 20 to show us how many sevenths there are. Okay, so we count on 14, 15, 16, 17, 18, 19, 20. That's 6. So we've got 2 holes and we've got 6 sevenths. And that's the answer. We're converting those improper fractions to whole numbers and proper fractions. And that then makes it a lot clearer. Right, now we have to try and work this one. So we've got 2 improper fractions. And in the middle, we have to put less than, greater than, or equal to. So we've got 7 halves, and we've got 7 fifths. So first of all, we go, right, how many 2s are in 7? Okay, so we've got 2, 4, 6, 3. 3, and we've got 1 left over. So it's 3 and 1 seventh. Okay, that is our answer. There we go. Okay, we've got 5 sevenths. How many 5s are in 7? 1. So that's 1 whole and 2 sevenths. So the first one was 3 and 1 half. The second one is 1 and 2 sevenths. So what do you think the answer would be? Which one is greater than? Which one is less than? Which one is equal? No, it's just showing us. There we go. Of course it is. Okay, because it's 3 and 1 seventh is a bigger fraction, it's a bigger number than 1 and 2 sevenths. When the numerator is the same, the greater the denominator, the smaller the fraction. Interesting. Of course, it's not often we have that, do we? So when the numerators are the same, greater the denominator, the smaller the fraction. That's a bit of a little cheat there, really. So if you look at it, if you look at that again, even before if we'd known that rule, if the numerator, the top number is the same, the denominator bigger, then the fraction is smaller. Each denominator, smaller fraction. I like that. That's a good little cheat. Okay, so using the same principle, we can't, because the denominator, the numerator, I'm afraid, is different on this one, so we do have to work it out. So first of all, how many 6's are in 24? And I did this one before, you remember. So how many 6's in 24? 6, 12, 18, 24. It's 4. Okay, 4 whole ones. There's nothing left over at all. So 24, 6 is 4. Okay, now we have to do the same 4 16ths. So 4, 8, 12, 16. Oh, strange, we've got 4 whole ones there too. So what symbol is going to go in the middle? Less than, greater than, or equals? If you said equals, you're right, because of course they are both the same. They are both 4 wholes. That nice. No rules on that one, I'm afraid. No little cheats that we can do. We have to try and work it out. Equals. Okay, right, now what we're doing is we've got 2 wholes and 3/5. Is that less than or greater than 9/5? So we've got 2 wholes and 3/5. And what we can do is we can say, okay, so fifths will be 5. All right, so in 2 wholes there will be 10. So then we've got 10 fifths, which is the 2 wholes, and we've got 3/5, so that would be 13 fifths. So 13 fifths, all these fifths will be greater than 9/5. Brilliant. Now we've got to try and work these out. We've got 28 sevenths and we've got 12 thirds. So how many 7's are in 28? 7, 14, 21, 28 is 4. 4 whole numbers. Okay, so the answer is 4. And then we say, right, how many 3's or thirds are in 12? So we have 3, 6, 9, 12. And the answer is 4 again. So in that one, we put equals, because they're both the same. There are 4 7's in 28. There are 4 3's in 12. So 28 sevenths is equivalent. It's the same as 12 thirds. There we go, to the bottom here. We've got 9 sixths and we've got 17 eighths. And again, we look at that. We say, right, how many 6's are in 9? So there's 1. We know you can only get 1 6 in 9. And again, if you wanted to, you could draw out 9 dots on your page and you could circle the 6 and it would then leave you with whatever's left over. So it's 1 whole, and of course it's 3 more to the 9. So it's 1 and 3/6. Okay, that's that. Now we need to work out the other one, the other side, 17 eighths. So an 8, how many 8's in 17? 8, 16 is 2. 16 7 is 1, so it's 2 whole and 1/8. So I'm saying that 17 eighths is greater than 9/6. Do you know what? I'm glad I'm getting these right, because I'd look a bit foolish if I wasn't. Right, and on the next one, remember the rule on this one. So we've got 20 tenths and then 20 ninths. And the rule was, of course, if the numerator, the top number, is the same, if the bottom, the denominator, is bigger, then the fraction is smaller. Whew, confusing stuff, eh? But if we work that out, if we look at it, we say, right, how many 10's are in 20? It's 2. Yeah, 2 wholes, which we know. And then we go to the other one and say, right, how many 9's are in 20? Well, there's 2 because it's 18, but then there are 2 left over. So it's 2 and 2 ninths. So it's 2 wholes and 2 ninths, which of course is bigger than just 2 wholes. So it does work. That little tip, it does work. So we'd have 20 ninths greater than 20 tenths. Again, glad I got that right. Now it's your turn to have a go at some of those questions on your worksheet. If you're not sure, what's really good about this is that on video on it is that actually you can go back and see what I've done, or you can look at the slides. Okay, so you can always watch what's happened if you're not sure. And also, you can come onto our GoToMeeting. There should be somebody there to help you. All right, so please have a go at that. Okay, when you do,